Hey algebra, sorry I couldn't be there again today. Was really hoping to be, but that's the world we live in. Unforeseen things happen, so I'm not going to be able to make it today. Hopefully I'll get back tomorrow. Um, Today we are continuing talking about linear equations, but we're going to go with graphing linear equations. And I want to remind you of our magical equation, y equals mx plus b. I mention this every time. This needs to get ingrained in your brain. We need to become very, very familiar with this. This is, once again, called slope-intercept form of a line, because m is the slope and b is the y-intercept. And we talked about slope last section. I think that was Monday, I believe we started that. So slope is the same thing as rate of change. We think of it more of a rate of change when we're talking about it situationally, but when we're talking about putting this on a graph and making a line visually, we refer to it more as slope. And for our purposes today, we're going to concentrate on rise over run. The vertical change going up and down for the rise, and the horizontal change going left and right for the run. All right, so that's our M. All right, our B, that is the y-intercept. And intercept, if you think of interception, ball coming, defender coming, they meet each other. They get the ball. All right, so y-intercept is where the line crosses the y-axis. So if I had a little coordinate plane here, and I want to draw a line, just like this. All right, we know that this is the x-axis going horizontally, the y-axis going vertically. So we're looking at the y-axis, and where it crosses the y-axis right there, that's our y-intercept. That's our B. All right, and a lot of times I think of it as B as the beginning point, because if you think anywhere on the y-axis, x has a value of 0. All right, so that's another important thing. X equals 0 on the y-axis. So I kind of think of 0 as the beginning point. So when we're looking at things like y equals mx plus b, we start at where x equals 0 and think anything times 0 is 0. So m times 0 gives us 0. So we're left with just b. So that's why I would refer to it as kind of the beginning point. So this should hopefully be a review of what we've been looking at. Now I want to look at how do we take an equation in slope-intercept form in y equals mx plus b and actually graph it. And once again, that beginning point, that's really the best thing. All right, so graphing linear equations, and I'm going to add to this graphing linear equations and y equals mx plus b form. So there's kind of steps here. Step 1, plot B, the y-intercept. All right, so we plot B, the y-intercept. Let me kind of give you an example here. Let's go y equals 2/3 x plus 7. All right, I'm going to make sure that I have room for everybody to see this graph here. So I got the y-intercept, I got the x-intercept. So plot B, the y-intercept, if I'm looking at this as y equals mx plus b, the b is 7. So what that means is on the y-intercept, I go up to where 7 is. Now obviously you'll have a graph with things labeled out. I'm going to put some grid marks on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Trying to make them as evenly spaced as I can here. So I would go up to where 7 is on the y-axis. So I go up 1, 2, 3, 4, 5, 6, 7. This is going to be my y-intercept. So that's my b that has a value of 7. Step 2. So my webcam froze on me. So we're going to have to do a little bit of editing to match these up. But I believe it happened when we were talking about using using the slope to find another point. So after we plotted our b, so we've looked at the y-intercept of 7, plotted it at 7 on the y-axis. Now we're going to go from that point and use the slope, in this case 2/3, to find another point. And it's really important here, and this is why I said we think a slope is rise over run. M is rise over run, meaning the vertical change over the horizontal change. And this is when it's best to use fractions. It's kind of nice when we have 2/3 here. So this just means from B, since 2 is positive, and in the y direction going up is positive, we're going to go up 2, and then 3 is positive, and the x direction going to the right is positive. So from here, we are going to go up 2. So up 2 this way, 1, 2, and then over 3 this way, 1, 2, 3. And we're just going to pretend that that matches up. And we're going to have a second point there. So we're going to say that was up 3. And then step 3 is very simple. Connect the points with a line. When you're doing this in Alex and in Study Island, they will have some kind of line tool for you. If you're doing this on graph paper, you should grab some sort of straight edge. I'm looking around. I got this random piece of wood here. There's a good straight edge. Boom. There's my line. And that's how you graph a linear equation in the form of y equals mx plus b. All right. Next part, I'm going to show you some problems in Alex. I created an assignment for you in Alex to complete. So I'm going to do a little screen recording here to show you the types of problems that you're going to get. Before I do that, I actually remembered I put a couple other things on there. These are every single line that is oblique, and oblique means diagonal. So every line that's diagonal, we can put in y equals mx plus b form. There are 2 types of lines that are not diagonal, and you might be thinking about horizontal and vertical lines. So before I get into Alex, I do want to talk about graphing horizontal and vertical lines. So horizontal lines obviously look like this, and vertical lines look like this. And the concept to getting the equations and graphing them is actually very, very simple, but it mixes some people up because it's kind of the opposite of what you think. So let me put another kind of coordinate plane up here. And what I'm going to do first, I'm going to look at horizontal lines. So horizontal lines, they have their own equation form. So just like oblique lines can be y equals mx plus b, horizontal lines are y equals some kind of constant. I use k for constant. All right, so a constant, remember, is just a number. For example, let's say we have y equals -3. All right, and if we have y equals -3, that means no matter what, the value of y is going to be -3. So if you think of some points where the value of y is -3, you just think of any random ones. 0, -3 works, 1, -3 works, 7, -3 works. All right, anything where the y is -3 works. It doesn't matter what the x is. So if you think about plotting these points, 0, -3, I stay at 0, and I go down to where -3 is. 1, -3, I go to 1, I go down to where -3 is. 7, -3, I go over to 7, and -3. All right, and all of those points combined are going to make that horizontal line, because everywhere on here, y is going to be the same value. All right, and this is, I think, where people get messed up. They think of horizontal lines go horizontally, the x goes horizontally, so they think it should be x equals a number, but it's flip-flop of that, because the vertical component doesn't change, and that's why they're saying y is going to be a constant. So the vertical component doesn't change, meaning it's going to stay flat. All right, and then if you think of this in terms of vertical lines, it's pretty much the exact opposite. All right, so vertical lines are going to be x equals a constant, because the x value is never going to change, the horizontal component never changes, which leaves you with a vertical line. So let me do it this way. 1, 2, 3, 4, 5, 6. Let's go right at 6 here. So if they gave you a vertical line like this that goes through where x equals 6, so this is the point 6, 0. If I want up here, maybe this is 6, 7. If I go down here, maybe this is 6, -6. All right, but the same idea, the x value is always going to be at 6, so the horizontal component stays constant, meaning you're going to be vertical. So that's why this is x equals a number. In this case, x would equal 6. All right, so now I'm going to get to the screen recording session to show you the types of problems that you're going to have in ALEKS. So first question I'm looking at is y equals 4x. And we've been looking at y equals mx plus b. And you might be wondering, well, this isn't anything like that. But if you think about it, this is really y equals 4x plus 0. All right, if we add 0, we don't really do anything. So we follow the same approach. We look at the y-intercept. In this case is 0. So on the y-axis, we go to 0. And then the slope here, we can look at this as a fraction of 4 over 1. So when we're trying to find our other point, from here, we go up 1, 2, 3, 4 over 1. We plot our other point, and then we take our straight edge here. We go to both points, and we're good. All right, so moving on to the next question here. Let's erase what we had on there. Same idea, 2x, but we can think of it as y equals 2x plus 0. So we're going to start, and we can actually just use a line tool if you want. You can start at 0 at your y-intercept and go up 1, 2, and 2 is the same thing as 2 over 1, so rise over run. We've got that. Can't get my, maybe I can move this. I can't get to my, there we go, check button. Okay, here's a full y equals mx plus b. So my y-intercept, this is where we start. We're starting at -1. So I'm going to put my point at -1. And our slope is -2. Now, since it's negative, I like to think of this as we go down. All right, so we're going to go down 1, 2, and over 1. When I put this as a fraction, I think of, okay, my rise is negative, so I'm going down there. My run is still positive, so I'm going down and I'm going to the right. And we mentioned earlier, I think it was on Monday, where we always try to keep going from left to right, just like we read. All right. Some people, when they see negative slope, they try to go down and they try to go left. Well, if you go down and to the left, you end up making just a positive line anyway, and that's not what we want. So down and to the right, get these 2 points, hit my check. We're good to go. All right. So same idea here. I'm going to try to go through these quickly because I have a 5-minute limit for this type of app. So -7 for my y-intercept. I go down to -7, and then my slope is 3. So from here, I go up 3 and to the right 1, and we're good there. Once again, I lost my my check. There we go. Moving on. This one we actually have a fractional slope. So same idea. We're going to go up to our y-intercept, at this case 4. Now, -1/3. We could think of -1/3 in a couple different ways. We could think of it as -1/3, because a negative divided by a positive is negative, or we could think of 1/-3. Same idea. Like I said, I prefer the rise going up or down like positive or negative, and the run always going to the right. So I look at it as -1/3. So when I have my line here, I already started at 4. I'm going to go down 1 and then to the right 1, 2, 3. It's really about just counting. All right. Next problem is going to be very similar. We're going to get a fractional slope. So start at the y-intercept, going up to 2, and then down 1 and to the right 2. All right. And as I'm doing this, whoever's controlling the video, if you need to pause or rewind for somebody, please take a chance to do that. If someone doesn't understand or needs to go back and see something, definitely that's what we want to do. So it's telling me I have 30 seconds left. We'll see if we can get through a couple of these. So x equals -4. The y component, the horizontal component is staying the same. So x equals -4, x equals -4 here, it equals -4 here, all along that line. That's what we're talking about. And then if we get a y, I might have to make a new version of this here. My time's about to run out. All right, coming back at you here. Another x equals 1. So that's another vertical line. So we go to where x equals 1 everywhere. X equals, let me get my line tool. X equals 1 here, x equals 1 here, and so on and so forth. So we've got that. Next question. Horizontal line. All right, y equals -1. So the vertical component is fixed. So we have to go where y equals -7. So y equals -7 here, and all over that line, which is how we know that that one is correct. All right, one more question here. So this is a little different. All right, so we're talking about two different types of intercepts. So we got an x-intercept and we've got a y-intercept. All right, so we've already talked about what do we do in slope-intercept form. We start with the y-intercept, and we could do the same thing here. The y-intercept is at 4, all right, where the line crosses the y-axis. X-intercept is really the same concept. Where does a line cross the x-axis? So if the x-intercept is 1, we go to where 1 is on the x-axis, all right. So I just wanted to throw this one in there just to get you thinking a little bit. So I can take my line tool and I can go to the y-intercept at 4 and the x-intercept at 1. And there's our line going through those 2 points. I think you learned a very, very long time ago that you only need 2 points to make a line. All right. But then after that, there are an infinite number of points that make up that line. All right. So way more. But as long as you can find 2 points, you can make a line. So if you have the slope-intercept, the y-intercept is 1 point. Use the slope to find another point, and you got your line. Here we have 2 intercepts. We got a y-intercept and an x-intercept. That's 2 points. That's all we need for a line. Okay, so your assignment, as you can see, is called linear equations and graphs. And when you log on to Alex, it should pop up automatically for you to take. There are 10 questions on here. I'm assuming that you can get this done by the end of the period. Now, I've made it so it's unlimited attempts. So the goal here is to get 100% by the end. And the way it works is, say you missed question 6, but you got everything else right, it will only make you redo a version of question 6. It won't give you the same exact question. It'll change the numbers up on you a little bit. But it's a nice learning experience, and everybody should be able to earn a 100% on this. So everybody's got this video. So if you forget how to do something, you can go back and look at it. You can also email me if you have any questions about this or any other assignment. And if you get finished early, just continue your path on Alex. There are some of you that still are behind on some study island assignments. you can try to get caught up on those. And hopefully things will align where I can actually come into school tomorrow and teach you in person. I'll see you when I see you.